Oh. So 2.2b is going to be a calculator with the calculator, front and back. See if I can maximize this. I want you to get calculator number 28. All right, let's do a recall. Back in Algebra 1, when we are looking for the average, do you guys remember the slope of slope between two lines has to be y2 minus what? y1 over x2 minus x1. There's actually an official word for this in calculus. It is called the difference quotient. And I know the wording sounds pretty obvious. We have a division quotient, and they both have minuses, the difference. And the average velocity in calculus is called the AROC. And AROC stands for the following. It is the average rate of change. And 2 days ago, we dealt with instantaneous rate of change, which was IROC, that we will do in a little bit. So with that said, Nick, let's read number 1.
A bowling ball is dropped from a height of 100 feet. Its height in feet at time t seconds is s of t equals -16 t squared plus 100. Find the average velocity over the time interval 100.
Let's underline average velocity. So if I give you average velocity, we have to use the slope, AROC. But if I just ask you for the velocity, it's going to be the instantaneous rate of change, where we use our derivative rule. So in this case, let's go ahead and reiterate something. S of t is the position. So basically, where is the ball? The S does not stand for seconds. The times do stand for the specific second or so on. So in this case, we have y2 is S of 2. And let's label x1 and x2 minus S of 1 over the x2 minus x1 is 2 minus 1. And notice I'm not writing out the formula.
You said position, right? Not positive.
Did I say position and write positive? You know, after lunch. Position. Did anyone write position on their notes? Good job. It's like I'm not listening to her. Thank you. Now, when we're plugging things in, we are going to plug it into the original function. So for S of 2, we have -16. I should open my parentheses. 2 all squared plus 100 minus -16 times 1 all squared plus 100. And you guys see why we have a calculator today? We don't want to do all that. Let's type that in. So on your calculator, it looks like since it's over 1, can we just type in the numerator? Yeah? Type them in. And I will say, if you're not using a calculator today when I'm allowing you to, maybe you don't need it on the test. When time allows. All right. This one is going to give us some negative number for a good reason. -40 something. Did anyone type it pretty quick enough? 48 feet per second. And this actually does make sense because the ball is being dropped. And the fact that it's being dropped, our velocity should be negative as well. Bless you.
Do we have to specify feet per second?
That would be a good practice. All right. So then let's go ahead and kind of recap 2.2 part A of yesterday. So Hamilton, go ahead and read this piece right here.
The instantaneous velocity is found by calculating the average velocity over a very small interval.
So instantaneous velocity basically is IROC. And if you did make flashcards from 2.2b, was it 2a or 2.1? You would have it with you. Is the derivative, the shortcut that I taught you guys yesterday. And that is because the average velocity is getting very, very, very incrementally small. So the change of time is reaching 0. And just in case you're thinking, well, remind me of the card, here I have it. As it is reaching 0, we have our derivative of the function. So then with that said, Let's go ahead and read this part, Hamilton, one more time because it's reiterating the same thing.
Instantaneous velocity is derivative of the position function.
And that was already mentioned previously. All right. For example number, should I call this one 1.B? 1.A, 1.B? There's no number. All right, Kinsey, let's read 1.B.
At time t equals 0, a diver jumps off the diving board that is 32 feet above the line. The position is given by s at time negative 15 squared plus 16 equals 32.
And it's saying, when does she hit the water? When you are hitting the water, what is our y is equal to position at? 0. So what I'm going to do is plug in, instead of s of t, 0. And then keep our function as I have on the right side. So on our calculator, we are going to plug in the easy one into y1 and the complex into y2. So here I go. And I happen to already have it. Wasn't that fast?
Yes.
Mm-hmm. And when it says when, it is asking us what is t is equal to, given s of t is equal to 0, to be very specific. And the first thing I want you to go from here is zoom 6. And we are going to modify the window accordingly. So we're all in the right gridded amount. All right. So can I see the very top of the graph right now? So go to your window. Now it's pretty obvious why we can't see it. If the y-intercept is 32, clearly we can't see the graph. So on y max, someone give me a number greater than 32.
50.
I'll take 50. Now go to graph. And now I can see the tip of it. So let's go ahead and write out the keystroke for your calculator on your paper if you forgot. It's going to be second calc. We're going to go to number 5 since we have 2 equations. You're either going to go to the left or the right depending on what the question is asking us. And you will enter 3 times. So let me model that with you. And if you can't find where the buttons are, tap on your neighbor, please. Second calc. The number 5. And we are looking for where it's going to be at y equals 0 to the right. And it's going to give us a clean number for this problem, which is not always the case. Press enter once, twice, and our third time. And what number does that x value give us?
2.
2. So we know the time is at 2 seconds when you hit the water. Tap on your neighbor if you're having trouble with the calculator. I can't see it. All right. For part B. Yes. Yours was -1 because you did not scroll to the right. When the diver is jumping off the board, they're going to hit a positive x value. All right, now let's go to our velocity. The next question says, what is our velocity? Now, does it say on here that we have the average velocity or just velocity? Just velocity means we're looking for the derivative, s prime. So I'm going to put on here, the velocity is the same thing as the derivative of the original function, which happens to be the following. Let's do our shortcut. If I missed you guys on the lesson yesterday, bear with me because I'm going to skip a step. Let's find the derivative of this. What is 16, -16 times 2? -32. And we have t to the power of 1, that is understood 1. What is the derivative of 16t? Just 16. Now, given that, we are now going to plug in the 2. So let's put on here s prime of 2, and 2 came from the previous problem for the impact as they entered the water. So we have -32 times a 2 plus 16. And it looks like this one is good to do mentally, negative 48 feet per second. And again, they're entering the water, meaning going down, so we have a negative in front of our velocity.
Where'd you get the 32 again?
We found the derivative.
Oh.
All right, let's move on to part C. When is her velocity equal to 0? So the velocity is equal to 0. So let's put on here v of t is equal to 0. When is our time? T is equal to.
You just set the derivative
Mhm.
to 0.
So I'm going to go ahead and take this, set that equal to 0. So 0 is equal to negative 32t plus 16. And it looks like we can solve this algebraically. Could I subtract 16 and divide it by negative 32? So that means our t is going to be how many? 0.5. So when? At 0.5. All right. So let's do a quick graphical value on this one. This person is on a diving board going down into the water. And that's going to help us understand what's happening on the next one. And actually, it is on this one. Okay, we did tell you guys about this yesterday. When the graph is positive to negative, our slope is what? Our slope is 0. So if I were to reiterate this, at 0.5, my slope is 0. So this order pair is going to be half 0 or 0.50. And by the picture, it does make sense that our slope is 0 when it's changing from positive to negative. Okay, last piece on this page. What is our velocity at 1 second? So let's go ahead and plug it in. The velocity at 1, and then the velocity at 1.5. And use a calculator if you need to, although we have clean numbers. Negative 32 times 1 plus 16. And then negative 32 times 1.5 plus 16. V of 1 is going to give us what whole number? Negative 16 feet per second. What would 1.5 give us? Negative 32 feet per second. And done with this page. So if you can control your calculator for this page, I think you're good to go. Let's move on to our next page. If you're still writing, I'm going to stay on this for 10 more seconds. And the only one we need a calculator on the back is the bottom word problem. All right. I hear talking. I hope you're ready. Okay, on the back. So we have this higher order derivative. So let's write on here. Derivative basically means velocity. If you want to put on there, it's the slope. Oh, there you go. Y'all can see it now. For word problem, we'll slowly get into that. Okay? And we're going to add something to the flashcard later on that's going to help us with the velocity and position. But right now, it's too early to share that. Kind of. But a little minimized version of it. All right. The main thing I'm going to look at is the first 3 derivatives. Yes, the derivative goes on forever until it flattens out. But I want to worry about these 2, and specifically, or these 3, within it, these 2. And I've already shared with you guys what the derivative symbolic notation looks like. And we have the common one, y prime, f prime, and so on. And just know that these will be used interchangeably. So let's go on to the example on the bottom. Which derivative are we going all the way down to? The third. So let's write on here the following. F single prime is our first derivative. What is the derivative of 5x to the power of 6? 30x to the power of 5. And here's a way to remember our sine and cosine derivatives. You guys ready? Is it pretty hot outside right now? Is it maybe hot, a little bit hot? Let's assume it's like just August and it's really hot outside. and I want to give you snow cone. And you're like, stories are stupid. It's really hot. I know band kids, you guys are outside all the time. And then I go, well, never mind. I'm hotter than how you feel, so I'm going to go ahead and take my snow cone away from you. I know, that's mean, right? I'm going to give you the snow cone and give it right back. Here's the idea. This story is only here to tell you how to remember your sine and cosine derivatives. Everyone ready? Derivative of sine is cosine. Derivative of cosine is negative sine. Then that means the derivative of negative sine is negative cosine. And they recycle. Derivative of negative cosine is sine. So what we wrote yesterday, if you can memorize this, great. But if you're not a good memorizer, use this phrase. All right? So when you get to the next test, write out snow cone and negative snow cones and kind of rotate them as you need. Is everyone good with that? And this is not my story, but it's going to work out. So I'm going to move on. So minus 3. What is the derivative of sine? Cosine. And now let's find the second derivative. What is our derivative of 30x to the power of 5? 150 x to the power of 4. I'm going to write minus 3 for now, but what is the derivative of cosine? Negative, so I need to make this positive, sine of x. And then our last derivative, the third derivative, 150 x to the power of 4 is going to give us how many? 600 x cubed. And then I'm going to circle my trig. And what is a derivative of sine? Cosine. And it says find the third, and we have. Done. So if this makes sense, use it. If not, just memorize it. No, just go with this right here. It doesn't matter. For here, cosine derivative is negative sine, so I had to put the negative in front of the negative 3 as well. That's why we have a plus.
So that one went to positive sign. Oh, I got it.
All right. Our last piece. Time looks good, is it? Yep, time looks good.
Well, when do we, what is this class?
Is it at 1?
Yeah, they sent a new schedule out.
Yeah.
3 days ago.
It's a confusing year, but that's okay. All right, last piece, I'm ready.
No,
Asher, let's read. Given f of x.
Given f of x equals x squared minus 11x plus 13, find the value of f of 1.1 out of calculator. Just kidding.
That wasn't funny, right? I should delete that. Okay, let's move on. Let's find the derivative. So given this right here, I know, if you laugh, thank you. That was just for you. I think she's laughing at it, right? What is the derivative of x squared? 2x. What is the derivative of negative 11x? Minus 11. And derivative of any constant is 0, that I'm not even going to talk about on that after the day, okay? So then I'm going to plug in the following. Let's see what number we're looking at. So this is our slope function. Let's go ahead and box that off. And I'm going to box it with the f prime. Second part now says, find the equation for the line that is tangent to x equals 1. So I want you to write out something. We need a point. The point starts at 1. The y point we do not know yet. So then for the y point, because this is f of x at this number, I have to go back to the original equation. It did not say f prime at that number. So when I do go back to that number, we're going to get the following. When I plug in the 1, let's plug it in. 1 squared minus 11 times 1 plus 13. What would that give us? 3? Okay. And then our slope for this one is going to give us, I need to plug in 1 into the slope function. So when I plug it in, I'm going to get 2 times a 1 minus the 11 That is going to give me -9, and that is our slope from the slope function. And then it says write the equation. So this is going back to algebra 1. Y minus y1. What's the formula right after that? M times x minus x1. And I want you to notice, the point is always x1 and y1. So when I plug it in, we get y minus the 3 is equal to -9 times x minus the 1. And I'm not going to solve the whole thing step by step, but your final answer, well, maybe I'm just going to leave it in this form. That's fine. I'm going to leave it just like this. Now, if this were to be on your test, it's going to tell you to write it as point slope, or not point slope, slope intercept form or whatnot. Okay?
-9x plus 12.
So -9x, how many?
Plus 12.
You have to do negative.
Is it plus 12?
Oh, I don't know. I was next.
Yep, I believe that is correct. All right, part C, Keith, let's read, evaluate.
Evaluate that line for x is equal to 1.1 using the equation of the tangent line. Parentheses the approximation.
So equation of a tangent line is this equation right here. And I'm just going to use my last equation, although this is even better. So we have y is equal to, so we're plugging in 1.1. -9 times 1.1 minus the 1 plus the 3. Oh. And that's going to give us about 2.1-ish. Someone check that on the calculator. And I should put in an approximation symbol. Is it really 2.1-ish? Okay, so then there's a reason behind this. Now it says evaluate using the original function. So f of 1.1, we're going back to the original function given to us, was 1.1 all squared minus 11 times 1.1 plus 13. And that number is going to give us about 2.11. Someone check that for me. Is it exact or about?
2.1.
That's exact? Okay. So let's write this in order pair. This one is telling us that our approximation is 1.1 and 2.1. And then the exact value is 1.1 and 2.11. And I know you're going to say, well, they're relatively the same thing. Let me explain what this looks like graphically. I want you to make a graph, a curve, and draw a tangent line. And I'm actually making this tangent line on the left side on purpose because when you do graph it, it is going to be on the left of the loop. And then let's also put this point right here is at 1, 3. Because the point on the line that it crossed was 1.3. And then I want you to go down here, put a dot side by side from the straight line to the curved line. The straight line is our tangent line. So our tangent line is going to be this point right here. And I'm going to write out 1.1 and 2.1. And the actual graph is our curve. And that point is at 1.1 and 2.11. So here is the idea. And I'm not going to write the sentence on this one. Just listen up. Is my approximation under or overestimated?
Under.
It is under. So imagine this then. If I had another graph and this were to happen on the right side, it'll be over approximated. It really depends on the concavity of your slope, your graph. Okay? Just heads up on that. We'll do more of these examples. It's a little awkward today, and that's perfectly normal.